Hi everyone. Let me explain some formulas for trigonometric function. First, draw the rectangle first, and draw the inscribed right triangle ABCs. That angle B is a right angle, and the point C. From the point C, draw the perpendicular lines to D on the baseline. So we got another right triangle ACD, right? Now we are focused on triangle ABC. And let's say, let alpha be the angle BAD. Let beta be angle BAC. And segment AC equals to 1. Now, sine beta would be CB over CA, right? So that means, in other words, hypotenuse CA, multiply hypotenuse CA by sine beta would be a height BC. And BA over CA is a cosine beta, right? And that means multiply hypotenuse CA by cosine beta would be adjacent AB. This is very important, okay? So the given angle is beta, and the adjacent is a ratio of cosine beta, and the height would be a ratio of sine beta. Now we are looking at the other right triangle AXB. See, so beta, cosine beta, sine beta. So the given angle is alpha. This would be a cosine alpha, and this would be a sine alpha. And the hypotenuse of this triangle AXB is a cosine beta. So the segment AX would be cosine beta by cosine alpha, and segment BX would be cosine beta by sine alpha. Okay. Now, let's see these angles here, because this would be alpha, and from this triangle ABX, angle ABX would be 90 minus alpha. But this angle would be 180, and we do have another right angle in here. So the sum of these two angles, this angle and this angle, has to be 90. But this is a 90 minus alpha, so this has to be alpha. So this angle and that angle would be the same. That means we use sine alpha and cosine alpha in this another new right triangle in here, CYB, right? And the hypotenuse of this triangle would be sine beta. So it should be this line would be sine beta by cosine alpha, and this segment would be sine beta by sine alpha, right? Now we are focused on triangle ACD. See the ACD. Now we are given angle is alpha plus beta, right? And hypotenuse is 1. So the height of this triangle, segment CD, would be sine of alpha plus beta. And adjacent of this triangle has to be segment AD is a cosine of alpha plus beta, right? Now, we are looking about the sine of alpha plus beta. Before we started, you see the triangle here, CDXY. So opposite side, segment CY equals to DX, and segment CD equals to segment XY. And the sine of alpha plus beta is a segment CD. See? From here to here. And this length is the segment of YB plus BX, right? The sum of these two lengths would be this length. So sine alpha plus beta is sine alpha cosine beta, right? Sine alpha by cosine beta plus cosine alpha sine beta plus cosine alpha sine beta, right? This is the sum formula of sine. Now we are looking for cosine alpha plus beta in beta, and this length is, the segment AX minus DX, right? This AX, and DX equals to CY. So we are saying cosine beta by cosine alpha, cosine beta by cosine alpha minus cy. So sine alpha, sine beta, right? Sine alpha, sine beta. And this is the sum formula of cosine, okay? Now, we are looking for another some formulas. Let's say the double angle formula, right? Okay. Here is the one. Okay. The sum of the sine formula in this formula, suppose beta equals to alpha, right? Then what happens? The left side of the formula is alpha plus alpha. That says sine of 2 alpha. And the right side, sine alpha by cosine alpha plus cosine alpha by sine alpha. So these two terms are the same. So it would be 2 times sine alpha by cosine alpha, right? And in the second formula, namely the sum formula of cosine, okay. Now, so beta equals, if beta equals to alpha, then what happened? Alpha plus alpha, then the left side of formula is cosine of 2 alpha, right? And right side is cosine alpha by cosine alpha minus sine alpha by sine alpha. So those terms are consecutive multiplication. So it would be cosine alpha squared minus sine alpha squared, right? So this double angle formula is derived from the sum formula of sine and cosine respectively. Okay? Okay, that's done. Bye.